Hello everyone, welcome again to our discussion of section 1.3 where we will be talking about linear functions. These are functions that generate a straight line, their slopes, and their applications, which means we will solve some word problems as well. Before we begin though, I wanted to remind you to please spend half an hour to 45 minutes to skim through this section 1.3 from your book. Just read through it, no more than 45 minutes, and then watch the video or attend the class and take notes on any questions you might have. Take notes on any important things you read in the book or things that come up in the class. And of course, review these lecture notes. Don't just take notes and not look at these until much later. As you take notes, read through them after a class, then the evening after you attend the class, or you watch this video, and remind yourselves of the things that were discussed. And then solve all the problems that were solved in the book as you read them without looking at the solutions. So the first time you read it, you may or may not want to solve those problems, but if you didn't solve them the first time on your own, go back to them and solve those problems in the book that were already solved again, without looking at the solutions. Do the same things with the examples you see me work on during the videos. In fact, I encourage you to pause the video repeatedly when I get to an example. Solve that example on your own on a piece of scratch paper, and then unpause the video and look at these solutions. And finally, please complete all the homework assignments by the due date. Don't put off doing the homework, and review these sections as we move further and further into the course. That helps keep things fresh in your mind, as well as the fact that this subject is cumulative, so it'll help you remember the skills we talked about in the earlier sections later, when you will again need those skills. So these 5 points that you see are the way to study mathematics and any quantitative subject. Any of your quantitative classes that you're taking. It might be a marketing class, it might be a finance class, an economics class, a physics or a chemistry class. In all those quantitative classes, this is the way to study. You read the section before it's covered, then you work out the problems on your own without looking at the solutions. Complete the homework and review the material again. Okay, so to begin with, in the last video, we did talk about this form of a linear equation. So linear equations are written in different forms. So that's one useful form, and it is called the slope-intercept form. Okay. Then, as we look at this graph, notice that B, which is this component of the equation, is the y-intercept of the graph, or the graph of this equation. So that is the y-intercept. So for a y-intercept, the x component is always 0. We've mentioned this before, right? And this point here, which is the x-intercept, has been shown by using this same equation that you see here. So simply you substitute for y with 0. As a matter of fact, let me do that right here. So if the question is, what does that value indicate? That is like that. So substitute for y with 0, because this is the x-intercept. equals mx plus b, right? Now solve for the x, because that is the x. So we have minus b equals mx, right? We're solving for x, so that means we need to isolate x. So then solving for x means getting rid of that m, so we end up with minus b over m. And that's what you see here, minus b over m comma 0, because that minus b over m represents this x quantity, x value. And of course, because that point is on the x-axis, so it is considered an x-intercept for which the y value is equal to 0. Okay? So usually in all the books that you pick up on algebra, you always see that the slope of a linear equation referred to with the letter m. So that's what I've used. So the variable m in the above equation represents the slope. And let me add something to this. It's not only the slope, it's the constant slope. It does not change. The slope for a linear equation or a straight line does not change. It's always a constant value. If you wonder about slope that does change, which is more what you see in the real world, that's the subject of calculus. Calculus mainly talks about slope that changes, or things that change, motion that changes over time, and quantities that change over time or over some other value. But in this class, we will only look at the constant slope. Okay, so, and once again, as a reminder, we mentioned this before, this line is read, the slope of this line is read from left to right, so it's a downhill sloping line. So the slope of this line, we would expect it to be a negative slope. Okay, uphill, a line that is heading uphill from left to right would have a positive slope. Okay, so the variable b, that's the one that we just talked about, represents a point 0 comma b, that's the y-intercept at which the graph of the line intersects the y-axis. Okay, so this is just summarizing what we discussed there. Okay, and here I'm mentioning that the name of that equation is slope-intercept form, because a lot of times when you read a book, they refer to that form of a linear equation as the slope-intercept form, so you should be familiar with that terminology. Okay, so the slope of a linear function can be found using this formula. And if you make a connection, when we were talking about circle, equation of a circle, I mentioned that you should, in your mind, make a connection between the formula for the general equation of a circle and the graph we were discussing at the time. It's no different than what we have here. So we have a formula. In your mind, you should make a connection between what goes on in this graph and what is referred to in this symbolic form. Okay, so this is just saying, if you have 2 points, and with a straight line connecting them, the slope of the straight line connecting those 2 points can be found by subtracting the y components of those points and dividing that quantity by the difference between the x components of those points. So why do we have y1 minus y2 and y2 minus y1? Both are acceptable. So what I'm trying to say here is that you are free to choose how the subtraction begins. So you can say either y2 minus y1, either this minus that, or y1 minus y2, or this minus that, right? You can say either. But as soon as you decide on the order of subtraction in the numerator, then you do not have an option for the order of subtraction in the denominator. If you picked y1 minus y2 like that, then you should also say x1 minus x2. So the order of subtraction must stay the same in the numerator and the denominator. You cannot say, for example, y1 minus y2 in the numerator and then say x2 minus x1 in the denominator. The order of subtraction must stay the same. That's why I have here y2 minus y1 divided by x2 minus x1. I'm not able to say y2 minus y1 and then x1 minus x2. I cannot say that. We cannot calculate this. You'll get an incorrect value for the slope. Okay? So you can say y1 minus y2 or y2 minus y1 as long as you remember that the order of subtraction must stay the same for the x components in the denominator. Okay? Talking about slopes, two cases are considered to be special cases. One of those is the horizontal line. It's a special case because any horizontal line will always have a slope equal to 0. Okay, the screen is going out of focus for no reason. Let's wait for it to... Okay, so I think now it's in focus. Okay, so the slope of a horizontal line is always 0. You might wonder, well, how is that? Well, let's draw a little figure here to show why is that. Suppose we have the x and y coordinates, and suppose we have this horizontal line going like that, right? So let's pick 2 points on this horizontal line. It doesn't make any difference where they are as long as they are on the same horizontal line. I'm going to pick those 2 points, right? So now let's label the coordinates of this point as x1, comma, y1. And let's label the coordinates of this point as x2, comma, y2. So, according to the slope formula, we can calculate the slope as follows. We can do slope equals y1 minus y2 divided by x1 minus x2, right? So, looking at these points, we don't have any numbers, right? But that's okay. y1 and y2, would they be different numbers or the same numbers? Think about it. These 2 points are on the same horizontal line. Would the y component for these 2 points be different values or would it be the same value? It'd be the same value, right? If y1 is 2, then y2 must be 2 because this is the same horizontal line going through that one single y values. In fact, all those infinitely many points along this horizontal line have the same y value for their coordinate. Okay, so that means we don't know what y1 and y2 are for these 2 points, but we know that they must be equal. So if they're equal, their difference should be 0 divided by x1 minus x2. Now, do we know what x1 and x2 are? No, but it makes no difference what they are because 0 divided by any quantity is equal to 0. 0 divided by a billion, it's 0. 0 divided by 1, it's 0. So we've shown that the slope of a horizontal line is always equal to 0. Okay? So these, what you see here, are examples of the equations of horizontal lines. So y equals minus 20, that means for all those, for a horizontal line that goes through 0, negative 20, all the y components for all those infinitely points that are on that horizontal line, all the y components are equal to minus 20. But the x values are going to be different, just like with this line that we've shown. But this, of course, is y equals some positive value, right? The same thing with a different notation. F of x equals 1.5 is another way of showing the equation of a horizontal line. The other special case of slopes occurs with vertical lines. The slope of any vertical line is always undefined. Now we ask, why is that? Okay, so let's do another graph for this case to explore why the slope of a vertical line is undefined. So suppose we have this vertical line like that, right? And we want to suppose we are given 2 points on this vertical line, one here and maybe one here, right? Let's label the coordinates for these 2 points. Suppose I say that this point, the lower one, has components x1, y1, and this higher point has components x2, y2. Right? Now, if we want to calculate the slope of between the straight vertical line that runs between these 2 points, we can apply the slope formula. y1 minus y2 divided by x1 minus x2. So, take a careful look at these 2 points. y1 and y2 can be anything, right? Because this vertical line goes from, with respect to the y-axis, it goes from negative infinity to infinity, okay, with respect to the y-axis. So they can be anything. So let's write y1 minus y2. It doesn't matter what the values of y1 and y2 are, okay? Now, take a careful look at x1 and x2. Would the values of x1 and x2 be the same or would it be different? x1, x2. Would it be different or the same? It would have to be the same because at that point along the line the x values do not change. Only the y values change. But the x value stays the same. Right? The x value for all the infinitely many points along this line, it's going to be the same. That means even though we don't know what x1 and x2 are, we know they must be the same value, the same number. So if they're the same number, then if we subtract them, what do we get? We get 0. So in effect, for a vertical line, when we calculate the slope, we always end up dividing by 0, which is undefined. Hence, we say that the slope of a vertical line is always undefined. Okay? Your book talks about a terminology that really belongs to the calculus class. But since they mention it, I thought we should talk about it, otherwise you might think it's something else, something that you don't know. In fact, they use the average rate of change. Average rate of change is something that, or rate of change for that matter, is a phrase you most commonly see in a calculus class. What does it refer to? It refers to a slope. It's a different way of talking about slope. It's the same thing. Okay, so I just wanted to mention that. So if you see this in the book, you know that's what it's referring to. Average rate of change is simply slope. For a linear equation, it's going to be a constant slope. Okay, so in each case below, here we begin solving examples. Throughout this section, as before, please, as soon as you understand or I explain that what the question is asking for, please pause the video without looking at my solution, work out the problems, and then unpause the video and look at my solutions. Okay? So if you do that, I'm sure you'll progress very, very fast and in an excellent way, and you'll end up doing excellent in this course. So in each case below, find the slope of the line that contains the shown points. So we have -3, 0, which is an x-intercept, and we have some point out there in the first quadrant, right? This is the first quadrant, second quadrant, third quadrant, and fourth quadrant, going counterclockwise, which has components 1, 2. So the slope, we can call this x1, y1, and that one x2, y2, right? We can label the points. So I'm assuming you've already solved this problem and you're watching the video to compare your solution with mine, which is fantastic. So the formula for the slope says that y1 minus y2 divided by x1 minus x2. Okay, so y1 is 0 minus y2 is 2 divided by x1 is -3 minus x2 is 1. So what do we get? We get -2 in the numerator, -4 in the denominator, which is simplifies to positive 2 over 4 because minus divided by minus is positive, and 2 over 4 is simplifies to 1/2. Okay, so that's the slope of that line. Does it make sense? It should make sense, right? Because this is a positive slope, and this is a line that is sloping uphill from left to right. Right? From left to right, going in that way, it's sloping uphill. So the slope, we would expect, even before this calculation, we would expect the slope to be positive. And in fact, we find that it is positive, and its magnitude is equal to 0.5, or 1 over 2. Here's another problem. Again, please solve this on your own. Pause the video, solve this problem on your own, find the slope, and then look at my solution. So here, the coordinates of these 2 points that are shown on the line are not provided, but it's no problem at all, right? We have the axes, the increments shown on the axes to guide us. So the coordinates of this point are -2, +2. Right? The coordinates of this point are 1, 4. Like that. So now we can label these points as x1, y1 and x2, y2. So now let's find the slope. I know in the previous examples I always used y1 minus y2 over x1 minus x2. Let me now switch to y2 minus y1 over x2 minus x1, because in fact it makes no difference as long as we keep the order of subtraction the same. So I'm going to say y2 minus y1 over x2 minus x1. Okay, y2 in this case is 4 minus y1 is 2 divided by x2, right? We did y2 minus y1, so now we should do x2 minus x1. x2 is equal to 1, and x1 is equal to -2. So minus 2, right? That minus is that minus. And x1 is -2, so that's -2. Okay, so we have, let's simplify. 4 minus 2 is +2 divided by 1 minus minus 2 is 1 plus 2, right? This minus will distribute itself to this, makes that positive. Then 2 over 3. So here's the slope. Does it make sense when you look at the graph? It should, right? Because this is a positive slope. And what do we have here? We have an uphill sloping line, so it must have a slope that is positive, like that. Okay. Here, we're not showing a graph, but we're simply given 2 points, and we are told that these points are on a straight line. Okay, so that's the underlying assumption here. So again, for these two, or even the rest of this, please make sure that you solve all these on your own. This page has 1, 2, 3, 4, 5, 6 problems on it. Please make sure that you solve each of these before you see my solutions. Okay, so let's label these just to make sure that we're on the right track. So I'm going to label that as x1 comma y1, this one as x2 comma y2, right? And we know this the slope formula. It is y1 minus y2 divided by x1 minus x2, right? We keep the order of subtraction the same. So y1, which is minus 1, minus y2, which is minus 13, divided by x1, which is minus 6, minus x2, which is positive 2. So let's simplify. Minus 1 minus minus 13, this minus distributes itself to this minus, makes it positive 13, divided by minus 6 minus 2 is minus 8. Simplify this a little more. Minus 1 plus 13 is positive 12, divided by minus 8. Can we simplify this a little more? Absolutely, right? Because 12 can be written as a product of 4 times 3. 8, and we keep the negative there, negative is there, but 8 itself can be written as 4 times 2. Right? So the 4 multiplied by 3, 4 multiplied by 2, because everything is being multiplied in the numerator and the denominator, so we can cancel the 4 and the 4. Okay? What do we end up with? We end up with minus 3 divided by 2. Minus 3 divided by 2. So this is a negative slope. That means the line must be sloping downhill when we read it from left to right. This one, pi. Pi comma negative 3. Pi is, as you know, is an irrational number. Pi equals negative 3. Pi equals 2. Okay, so it's pi something you'll see a lot in trigonometry, which is Math 127, but rarely, sometimes, it pops up in this course as well. But it doesn't matter. It's just like any other point. We should be able to find this slope of the straight line that connects these 2 points. So the slope formula is y1 minus y2 divided by x1 minus x2 equals, so let's label these. We have x1 comma y1, x2 comma y2. So y1 in this case is minus 3, minus y2, which is 2. x1 is pi minus x2, which is pi, right? So we have minus 5, minus 3 minus 2 is minus 5. pi minus pi is 0. So the slope of the straight line that connects these 2 points is undefined, right? Because of this 0, we're dividing by 0. So that means this line that connects these 2 points is vertical. Undefined, the line is vertical, as we showed earlier, right? Part E, again, I'm hoping that you've already solved these on a piece of scratch paper and you're just watching my solution to compare with your solution. I'm counting on you that you're taking this small but important advice that I have as we go through the course. So here, this is another way of showing the x and y values for a point. Okay, so instead of saying x and y is like this, they say f at 1/5 equals 1/2. So what they're really saying is saying that 1/2 is the x value. So 1/5, sorry, 1/5 is the x value, and this 1/2 is the y value. Let's call this x1, comma, y1, right? Same way here. So that is an x value, and that is the y value for that function. But let's label these as x2, comma, y2. Okay, that's all. So they're giving us the information we had up here, but they give that information to us in a different way. So we become familiar with various modes of various ways that information can be provided to us. Okay, it's the same type of information. It's the coordinates of a pair of points, but shown to us in 2 different ways. But we can decipher the code, right? That was easy. So now let's find the slope, which is y, let's this time say y2 minus y1 divided by x2 minus x1, right? Keep the order of subtraction the same. So what is y2? y2 is minus 11/2 minus y1, which is 1/2, divided by x2, which is minus 1, minus x1, which is 1/5. Right? Like that. So the fractions in the numerator have the same denominator. So we can easily sum up, add or subtract the numerators, whatever they are. So minus 11 minus 1 is minus 12/2 divided by, we get to the denominator. The denominator is, these two do not have a common denominator. We need to find the common denominator and combine these 2 terms. So let me do that here if you don't mind. The denominator of -1 is what? Do you know? The denominator of -1 is 1. So what is the common denominator between 1 and 5? What would be the common denominator? It would have to be 5. 5. Now, this fraction is already has a denominator equal to the common denominator. So we leave it alone. The denominator is happy, we leave it alone. How about this? Well, this is 1, but the common denominator is 5. We need to make this denominator equal to 5. The way we do that, we multiply the denominator by 5. But we can't do that to the denominator and not do the same thing to the numerator. So we also multiply the numerator of this first fraction by 5. Okay, so what do we get? We get 5 times negative 1, right? Time, we're multiplying right there. We're multiplying. So 5 times negative 1 is minus 5. This fraction stayed the same as it was. We didn't have to do anything to this, right? Because the denominator was already 5. So minus 1. So what do we end up with? We end up with negative, I'm keeping this as a fraction and not simplifying it to negative 6 for a reason. You'll see in a minute. I want to make a point. So negative 12 over 2 divided by minus 6, right? Minus 5 minus 1 is minus 6 over 5. So now we have a complex fraction. We can't leave that like this. We need to simplify a complex fraction. The easiest way to simplify a complex fraction is this. Take a look at the numbers that are farthest away from each other, negative 12 and 5. Multiply them, multiply the farthest numbers from each other and put the result in the numerator. So negative 12 times 5 in the numerator, divided by, multiply the numbers that are closest to each other, 2 and negative 6, and put the product in the denominator. Done. So that's the easiest way to simplify a complex fraction. Multiply the farthest numbers from each other, put them in the numerator, multiply the closest numbers to each other, and put them in the denominator. So let's simplify. So we have, right, the rest of this here. Minus 12 times 5. I could simplify it, but or I can multiply it, but let me keep it the same, over minus 12, right? So minus 12 and minus 12 cancel out because we're multiplying. Let me quickly explain here because I've seen this error happen. If you had, instead of this, if you had negative 12 plus 5 over negative 12, could you simplify this and this negative 12? No. Please, if you're one of those people who is doing that, please stop doing that. I've seen it too often, and it's completely wrong. You cannot simplify this with that. You can only simplify terms like in a fraction if they're being multiplied by each other, which is what we have here. If the terms are being added or subtracted, you can't do that. You can say this and that if they're being added or subtracted in the numerator or the denominator. Okay? In this case, we can though. And after simplifying, what do we get? We get positive 5. So that's the slope of the straight line that connects those 2 points. Okay? In the next example, and I'm banking on you having solved these, okay? I'm trusting you that you've already solved these, and now you're waiting for my solution. So y equals 3/4 is a horizontal line. So this equation represents a horizontal line. And what did we say on the previous page? We said that horizontal lines, any horizontal line, has a slope of 0. So right away, based on that, we say that the slope is equal to 0. X equals 8 represents a vertical line. If it's a vertical line, what did we say about vertical lines? We said that vertical lines, all vertical lines, have an undefined slope. So m is undefined. Okay, that is minus 12. Okay, so this last one, the easiest, well, not quite, because that's also minus 2x. So we have 2x terms here. So before we write down the slope, we need to combine those two x terms. We cannot have them looking separate like that. So let's take the common denominator. So we have 4, let me rewrite this so it looks better. 4x, this x is being multiplied by the numerator, 4x over 5 minus 2x, right? So at this point, what is the denominator of the minus 2x term? It is equal to 1, right? So to combine these two x terms, they're both x terms, so we need to combine them. We need to have common denominator. Okay, so what would be the common denominator? The common denominator would be 5, right? The common denominator would be 5. So this first fraction already has a denominator equal to the common denominator, so we leave it alone. It's happy. It's got what it needs, right? A denominator that is equal to 5. How about this one? No, far from it, right? So we need to get this 1 to become this common denominator. How are we going to achieve that? Well, we're going to multiply this fraction, the denominator, by 5. Wonderful. 5 times 1, it's going to give us the common denominator we need for this term. But hey, we can't do this to the denominator and not do the same thing to the numerator. So we have to multiply the numerator by 5 as well. So the objective is to get the common denominator, but to get there, we can't just change the denominator and leave the numerator alone. A single fraction should be changed as a whole in order to obtain the common denominator for it. You can't do something to the denominator and not do the same thing to the numerator, okay? So now we can work with these because 5 times 1 means this whole fraction has a common denominator too. So we have the common denominator. Let's subtract the numerators. What are the numerators? The first numerator is 4x. The second numerator is minus 5 times 2x, so 10x. Okay, and I'm going to put the rest of this over here, like that. So now y equals, let's subtract, 4x minus 10x is equal to minus 6x over 5. Or, so we're done there. This is the final equation. And, or we can rewrite it as, or y equals minus 6 over 5x. These two equations are exactly the same, but they're written differently. So what is the slope of this equation? It is minus 6 over 5. Remember this form that we talked about on the first page? Let me bring it up. Remember this form, slope-intercept form? That equation is being written in this form. But the b, or the y-intercept, is 0. That's why you don't see it. It's gone, because it's equal to 0. So the slope of that line is minus 6 over 5, which would be equal to the m here. Right? Okay, so the slope is equal to minus 6 over 5. And that is the slope of that equation. Okay. So here we have an application problem. Application problems are useful because you want to know how to put these mathematical skills that you learn to practice in different real-world situations. So that's why they are important. They bridge the gap between what's purely mathematical and applications in the real world. Okay, so the population of Detroit, Michigan, it says, decreased from this amount, 1,027,974 in 1990 to 701,475 in 2012. Find the average rate of change. That's why, because your book uses phrases like this here, find the average rate of change. So they're asking you to find the slope. So you see that, please don't be confused because average rate of change is the same thing as a slope, which we've been calculating throughout this video. In the population of Detroit, Michigan, over the 22-year period. Okay, so here, when we solve these kinds of problems, let me bring you back. When we deal with these kinds of problems, the points for which we were calculating the slope of the straight line that connects them were given to us. They were given to us. Here, here, and here, they were provided to us. But in the word problem we have before us, we need to extract that information for those 2 points on our own. So the methodology is the same, but we need those 2 points. We need to find those 2 points on our own. Okay? That's the only difference between this and those other problems that we did so far. So let's find the points. Where are they? Well, remember what we talked about earlier, probably in the first video, right? Look for independent and dependent variables. That's the first thing we're going to look for. So, because independent variable is the x value, dependent variable is the y value. So as we read this problem again, let's focus on what depends on what. Okay, so the population of Detroit, Michigan decreased from this to that over this time. So definitely the independent variable here is which one? We have 2 quantities, right? We have the population. Here are the 2 quantities we have. We have the population, and we have the year or time. Let's call it time, 1990, time, right? Those are the only 2 quantities we've got. We have nothing else. So which one of these is the independent variable? Which one of them is the dependent? Which one dependent, which one independent between these 2? You have to make that determination in your mind. Think about it. Before you see me write this down, think about it. Pause the video, please, and think about it. Look at the problem carefully and make up your mind which one of these 2 quantities, time or population, would be dependent and which one would be independent. Okay? The independent one, I'm assuming you've done that. You paused the video, you made your decision, now you're back. So, the time is independent, right? Time is running independently of anything else that is happening in the society or nature. It's just happening. Time is the independent one. So that would be time, and the y value, which is the dependent, would be population. Population depends on time. Okay? As soon as you establish that, Now we have something to work with. So let's set it up. Time, comma, right? Instead of x comma y, we have time comma population, right? So time comma population. So knowing that, then let's look at the quantities we have and categorize them here as 2 points. So we're going to have 1 point here and 1 point here. In 1990, right? In 1990, comma, the population was this much, right? 1,027,974. That's one of the points. Remember, we do not have the points. We need to construct them on our own. Because they're asking us to find the slope, but they don't give us those 2 points we need. So we need to construct them. And this is how we do it. We establish the independent and dependent variables, and then based on that, we categorize the quantities we have. Okay, so that quantity is categorized as time. This is categorized as population. So the other point. Then in 2012, so that's the time for that point, the second point, 2012, the population went down or decreased to that much, or was that much. It was that much. In 2012. 701,475. Right? So we now have both the points we need in order to calculate this slope. So let's calculate this slope. So we have, so all of this leads to that, and that leads to this. Okay, so now we have the slope. You can label these if you want, if it makes it easier. x1 comma y1, x2 comma y2, right? The slope formula says y1 minus y2 divided by x1 minus x2. y1 is this quantity minus y2, which is that quantity, x1 is 1990 minus x2, which is 2012. So we already know that this reduces to 22 years, right? And also minus 22. We would expect this slope to be negative, right? Because there's a decline in the population. So before we even calculate the slope, we know our slope must turn out to be a negative value. And it is turning out that way. Then let's subtract those two quantities. Here's my calculator to help me with that. Okay, so I'm going to say 1,027,974. I'm double checking to make sure that I entered this quantity correct. 102.79, yes, minus 701,475. So that's what we have, 326,499. So let's write that down. 326,499. So let's divide that number by minus or 22, and then we'll keep the negative next to it. Okay, so here's my number. Divide that by 22. There we have. Okay, so we have that slope. So minus 140 or 14,840, and I'm going to round this to just one decimal value, 9. So I had 0.86, but I'm rounding it at 0.8629. Okay, so here is our slope. And as we expected, it's a large it's a small negative number, right? Because negative numbers decrease in size as we approach negative infinity. Okay, so here number 3 is another problem we have here. It says in 1938 the minimum wage in the United States was 25 cents, right? By 2009 the minimum wage had increased to $7.25. Find the average rate of change. Again, that phrase, average rate of change, means slope in the minimum wage from 1938 to 2009. So before even calculating this slope, we know it has to be a positive slope, right? Because the wages, the minimum wage went up over this period. Just like before, we need to establish the independent and dependent variables, right? So we have two quantities here again. We have 2009 and 1938, so that's time, right? That variable, that quantity represents time. And then we have money, the wages, to be specific. The minimum wage is another quantity we have. So which one depends on which? Does time depend on minimum wage, or does the minimum wage depend on time? Make that decision in your mind before you see this solution, and solve this problem on your own before you see my solution. Please do that. Okay, so I'm assuming you've done that, and now you're back. So independent, comma, dependent, right? Because we know this is x comma y. X value is always independent variable, and dependent variable is the y variable. Okay, so let's see. In this case, the independent variable, again, I hope my response agrees with your response, is time, the year, right? Those are independent. And then dependent is the minimum wage. Okay, so let's set up, we're asked to find the average rate of change, right, which is slope. So we need at least 2 points to establish that. So let's find our 2 points based on this information. So we know that time in 1938, in that year, the minimum wage was 25 cents. And in 2009, right, I'm putting year where the time is for independent variable, which is x, comma, minimum wage went up to $7.25. So now we have 2 points. These 2 problems, this one and the one I solved before, are extremely important because they convey to you a very important concept that's used even in graduate college and advanced mathematics, which is to establish a function that is an appropriate function for data. In the data, you must establish what depends on what. I mean, we're doing examples here in Math 124, but I've done this in real world in graduate college, in my graduate studies as a graduate student. I've done many analysis like this. You get a lot of data and you need to figure out, sometimes it's easy to figure out what depends on what, but not always. Variables are not always that easily connected. So you need to really think about and talk to other people about their opinion as to what variable might depend on what variable. Okay? So that's why I say these 2 examples are very important, because they are having you think in that direction of looking at the data or information and establishing what depends on what. Very, very critical in all quantitative subjects that we study. Okay, so now that we know that for this problem, let's find the slope. The slope is y1 minus y2 over x1 minus x2. And for the sake of convenience, if it helps everyone, let me label these x1 comma y1 and x2 comma y2. So y1 is 0.25 minus y2, which is 7.25, divided by x1, which is 1938, minus 2009. Right? So the numerator is simply minus 7. Right? The denominator, here's the calculator, 1938 minus 2009, minus 71. Okay, so negative divided by negative is positive, 7 over 71, and calculating that quantity, 7 divided by 71, we have 0.09. So I'm going to round this to 0.1. We could do that for this purpose of this problem. Either that, or we can keep this and say 0.099, or we can round that 8 to 9. It makes no difference. So let's do that. So equals 0.09 and 0.09 and 9. So that is a slope. That is a very small positive slope. So it tells us that the minimum wage increased, but at a very, very small rate it changed. Very slowly it changed. Okay, so here it says, in each case followed below, find the slope and the y-intercept of the line that has the given equation. Remember, as every time they ask you for the slope and the y-intercept, write your equation, write your linear equation in y equals mx plus b form. Because once you write the equation, if the equation is already in that form, which is this one, then you're fine. Then you simply write down the slope and the y-intercept. But if it's not written in this form, then you want to put it in that form, because having the equation written in this form, you readily know what the slope is and what the y-intercept is. Okay, so that statement is a clue to you to use this form. Slope, intercept, form. Okay, so we already know that this equation is in that form. So the slope of this equation is 3/5. And the y-intercept is equal to -7 or 0 comma -7. Okay, y-intercept 0 comma -7. On a paper, if you say -7, it's acceptable. If you say 0 comma -7, I accept it. But in the computer, please make sure before you enter your answer for a question like this, I'm sure you're going to have homework questions in the computer in MyLabMath that would be like this. So please make sure before you enter your answer in which format the computer accepts your answer. If it accepts as a -7, enter it as -7. If it accepts it as 0 comma -7 like this with parentheses, then enter it like that. Okay. So this one, we know that this is a horizontal line once again, right? A horizontal line. Therefore, the slope is going to be equal to 0, or is 0, right? We know, we already talked about that. The slope of any horizontal line is always 0. Okay, and y equals 4/7 means the straight line, the horizontal line for which the y value is always 4/7. The x can be anything. The x can be infinitely many numbers. But the y value is fixed at 4/7. So this is a horizontal line. Okay, and then the y-intercept is itself 0, 4/7. Is 0, 4/7. Again, for your online homework, please make sure you before you enter your answer, you know in which format the computer accepts your answer. But that is the y-intercept. That's how I would expect the computer would accept your answer. But if you write 4/7 on an exam, on a paper exam, or you write this on a paper exam, I accept both. Okay? Because either one of those answers tells me that you have understood the subject, which is wonderful. So this x equals minus 2/5, that is a vertical line, right? I have enough room here so I can draw a little sketch of it. X equals negative 2/5. Negative 2/5 is about a little less than 1/2, right? A little less than 1/2. So if this is 1 and that's 1/2, then negative 2/5 would be somewhere here, like that. Okay, that's x equals minus 2/5. So we do know that this line has no y-intercept, right? Because it's a vertical line parallel to the y-axis, no y-intercept, but the slope of a vertical line is undefined. And no y-intercept exists, okay, because of that. That. Okay, this one. This is what I was saying, that if you're given a linear equation and you're asked to write down the slope and the y-intercept, then put this line in, or write this line in y equals mx plus b form. So let's do that. Like that, okay? So first, let's move the 2x to the other side. When we do that, it changes the algebraic sign from positive to negative to something opposite, right? Minus 2x plus 12. Now let's divide both sides by negative 3. What do we end up with? On the left, things are easy. We end up with y. On the right, minus 2x over minus 3. That's positive 2 over 3x. Minus 12 divided by minus 3, that's minus 4. Right? So now we have that. So given this equation, then we have m equals positive 2/3, and y-intercept is equal to 0, comma, -4. Are you pausing the video and writing down your own solution before you're looking at my solution? If you are, wonderful. If not, please start doing that. Okay, I want to build up your skill, but as we go through the semester, and the only way I could do that is that if you keep your end of the bargain and pause the video before and work out the problems on your own before looking at my solutions. Please don't ever skip that. That step is critical to your learning in this class. This is an easy subject. I want all of you to end up with an A, so please don't just watch the video, work out these problems on your own. Okay, so this one. So go ahead and pause the video. If you haven't done that already, that is, solve this problem, find the slope and intercept, and then come back to the video again. I'm assuming you've done that. So the first thing I would do is just move the 5x to the other side. And it's positive on this side. When I move it to the other side of the equality symbol, it will be negative 5x. So negative 2y. And at the same time, I will do the same thing with 9. Okay? So minus 2y equals minus 5x minus 9, right? Moving terms across the equality symbol means that you got to change the algebraic sign, and that's what I did. Then divide both sides by -2, right? Divide this side by -2, this side by -2. On the left, things are easy. Y, -2 and -2 cancel out, right? On the right, -5 divided by -2, it's positive 5/2 times x. Then -9 over -2, that's positive 9/2, plus 9/2. So now we have our equation written in y equals mx plus b form. So I forgot to write that here. So first, write the equation in y equals mx plus b form. Okay, that's what we did. That's what we did here. Okay, so now we can easily see what the slope and the y-intercept are. Those two quantities are. So slope is 5/2, right there. And the y-intercept is equal to 0, 9/2. Like that. Okay. Making sense? I hope so. So this last equation here, we have 0.3 plus x. That's already written in y equals mx plus b form, right? It's no problem if we can easily switch these. So we can put x plus 0.3. So f of x equals x plus 0.3. That's the same equation as that. So the slope is equal to 1. Y-intercept is equal to 0, 0.3. M equals 1 and equals that. Okay. All right. The next problem, it says, in each case below, graph the equation. Hint, it's easier if you use the intercepts, and it's covered right there. So it's saying use the intercepts. That's the hint we have, right? With straight lines, that's always the easiest way. With lines that are not linear, straight, then we would need more than the intercepts. We would need other things. We might need a couple of more points. We might need asymptotes and all of those things. So I think later on we get to those kinds of graphs too. I mean non-linear graphs that are not straight lines. I think in this course we get to it, but maybe in much, much later sections. Okay, so this one, let's first find the intercepts. So, because that's a straight line. So the x-intercept, we did this before, remember, in the earlier, one of the earlier sections? X-intercept means that the y value is 0 and we ought to be looking for the x quantity. So let's substitute in that equation for y value, substitute with 0, and let's find x. So 2x plus 3 times 0 equals 15. So 2x equals 15. X, we're solving for x, right? So we need to isolate x. We need to get rid of the 2, divide both sides by 2, 15 divided by 2, or this is 7.5, right? So x equals 7.5. So the x-intercept is 7.5 comma 0. That's the x-intercept. Okay. So let's find the y-intercept. The y-intercept is when the x value equals 0 and we'll be looking for y. So in that equation, one more time, let's substitute for x with 0 and solve for y. Like that. Okay, so 3y equals 15. We're solving for y, right? So we need to isolate y, which means we need to get rid of this 3. How do we do that? Divide both sides by 3. Okay, so we have the y-intercept is 0 comma 5. Like that. Okay, so let's plot these 2 points and draw a straight line right through them. So this graph area leaves it up to us to increment this, and these are nice easy numbers. So maybe I can 1, 2, 3, 4, 5, 6, 7, and then 7.5 would be somewhere there. Yeah, let me do that. So each of these boxes is 1 increment. So 1, 2, 3. I'm going to be off this line a little bit. Let me stretch this line a little further, like that. So 4, 5, 6, 7.5. That would be right there. Okay, 7.5, right there. That last increment is 7.5. So that's one of the points. And then the y-intercept is 0 comma 5. So 1, 2, 3, 4, and 5. That's 0 comma 5. That is 0 comma 5. That point is 7.5 comma 0. Right? We plotted these 2 points. Now let's draw a line right through them, and I need to grab my ruler from my backpack here. Oh, did I bring my ruler? It doesn't look like it. Okay, that's fine. So I'm going to use this piece of scratch paper as my ruler. So we connect those 2 dots or 2 points with a straight line, like that. Okay? Like this. All right. Like that. Here we have more word problems, which are application problems, and these are good because we need these tools we learn about in mathematics to actually tackle real world problems. And these problems give us the opportunity to do that. Okay, so Richard is considering relocating to an assisted living facility. He learns that there is an initial community fee of $2,250 and a monthly charge of $3,380 for level 1 care. Okay? So, I don't know if you've taken Accounting 101, but if you have, they always, one of the first things they teach you is this, that total cost, which is what they talk about here, total cost. So from Accounting 101, right? From Accounting 101, total cost is equal to the fixed cost plus the variable cost. Like that, right? So bring that and apply it to this information we have been given. It says that initial community fee of this much and a monthly charge of that. So write an equation that can be used to determine the total cost for T months of level 1 care. Okay, so what is our, in this equation, what is our fixed cost and what is our variable cost? Because we're looking for the total cost, right? We're looking for this. And the total cost is equal to fixed cost plus variable cost. So and I hope you've solved this problem before you see my solution. I'm just reminding you, if you haven't, please pause the video, do your own work on the paper, then come back to this. Okay, so now I'm assuming that you've done that and you're back. Welcome. So the initial community fee, that's the fixed cost. It's a one-time charge, right? It's a fixed cost. Then a monthly, which means it's a recurring charge, a monthly charge, a recurring charge of $3,380 for level 1 care. So that the charge of $3,380 is the variable cost. So let's put that in equation, keeping in mind they want us to use the T variable for months. So I'm going to use the same variables they ask us to. Okay? So total cost, C of T, is equal to the fixed cost, $2,250, plus the variable cost, $3,380. So now I intentionally left the T off, the variable T. The variable T should be either here, attached to this quantity, or attached to this quantity. To which quantity should it be attached? Have you made that decision yet in your own solution? I hope so. Well, it should be attached to this one, not to the fixed cost. Fixed cost is not depending on time or the number of months. It's the variable cost that is a monthly charge. So the T is here. Okay, so here is the equation. And then it says, find the total cost for 20 months. And T represents number of months. Every time we assign a variable in an equation, we must know what units and what quantity it represents. This is especially very, very important when you're taking biology courses, chemistry courses, physics courses, those types of courses. Okay? So T here represents not only time, but in which unit? Daily, monthly, weekly, yearly, what is it? It's monthly. Okay, we need to know that. So here they say, find the total cost for 20 months. So this 20 matches the unit of t. They're both in months. But if this was in, let's say, weeks or years or whatever, that was different than months, I would have to convert that other unit to a monthly unit. Okay? So keep that in mind. That's why units are important, for the fact that if they're different, we need to convert from one unit to the other. But in this case, we can just plug in 20 for t. So cost, the total cost for 20 months is equal to 22,000, right? 2,250 plus 3,380 times 20. So we have 22,000 that plus, let me make use of my calculator here. Okay, so we have 3,380 times 20, 67,600, right? 67,600. 600. Okay. All right. So adding that to 2,250, we have $69,850. That's the total cost. Okay. The next problem, number 7, please make sure that you pause the video, solve this on your own, and then come back to the video. So it says Susie's Cookie Company has fixed costs of, they already called it fixed cost. Over there in the previous problem, they didn't call it fixed cost, right? But now they call it fixed cost right away. And variable cost, wonderful. Of that, per dozen, $4.25 per dozen gourmet cookies that were baked and packaged for sale. Okay, write an equation that can be used to determine the total cost when X, we need to use these variables that they're asking for. Total cost when X dozens of cookies are baked and sold. So that $4.25 is per dozen, right? So that's the unit, per dozen. Okay, so the total cost, let's call it C this time, cost depending on X, because that's what they want us to do. The previous problem depended on T, this is X, right? So X is the independent variable here, and C is the dependent variable. In the previous problem, T was the independent variable, and C was the dependent variable. Okay, so we have the fixed cost, 1,250, plus the variable cost, $4.25 times X, right? The variable cost is associated with the variable, independent variable. Okay, so this is our equation for the total cost. You do not want to attach this X with this, right? This is the fixed cost. So it does not get associated with any variables. Sometimes I see that on exam papers. Okay? So for part B, it says determine the total cost of baking and packaging for sale of 85 dozen gourmet cookies. And that reminds me, when we assign a variable, we need to define it. So X is this, look how they define it. X dozens of cookies. So dozens of cookies. Okay, so that's what the units of X are that. So 85 dozen gourmet cookies, that means we can, given those kinds of units, we can plug 85 directly into X. Okay, so let's do that. I don't know why the screen all of a sudden has become fuzzy. Sorry about that. I just noticed it. So let me focus. Okay. So now cost of 85, total cost of 85 dozen cookies is equal to, we're plugging in that equation, right? 1,250 plus 425 times 85, 1,250 plus, let's bring back the calculator. We want to calculate this quantity, right? 4.25 times 85. $361.25. Like that. Okay. So we're going to make that addition. So 361.25 plus 1,250. So we have 1,611 and 25 cents. Like that. Okay. All right. So we have come to the conclusion of another section in this video. Let me remind you, for the next video and all the consequent ones, please make sure that you pause the video, solve all the problems on your own, and then look at my solutions. I cannot repeat that enough, because without that step, all of this will be just watching any other video without the purpose of learning the subject. Okay? With the purpose of learning the subject, that becomes a critical step. You need to solve these problems before you see my solutions. Okay? I hope you'll stick to that strategy. And so for now, have a nice day, and I'll see you again all next time.